energy at any point defines the state. We use energy to define the state. It is not a target variable in its own self. So like whenever you are calculating trajectory or whatever of any particle, so you want to know how that particle will behave, right? Energy explains how it will basically behave or how the system is formed or whatever and whatever. So what happens in classical physics, you are going to calculate basically these variables, momentum and energy. Using that you will calculate whatever and whatever. In quantum mechanics, there is one basically target variable that you have to calculate for any particle called wave function. In classical mechanics also there is concept of wave function. It is something like this: any wave is there. So how you will define basically the displacement of each and every particle of that wave is the wave function, right? It is a function of time, that it depends on time, it depends on distance of where the string is, if we are considering on a string. In quantum mechanics, what is that you have a book. In classical mechanics, a wave is propagating, you define. In quantum mechanics, this book is present, you can define a wave function for this book as well. In classical, you will define mass, acceleration, momentum and energy and whatever to this book. In quantum mechanics, actually it's kind of exaggerated. You define it for particles, elementary particles. Wave function for the reason that particle will behave both as a wave and as a particle. So electron is also a wave, also a particle. You can calculate wave function. And this is the only thing you calculate. Using the wave function, you can predict between what and what position that particle or that wave packet, you can call it wave packet, something like this. Imagine this is a point when waved from very far. Classical mechanics says it is at this position, alright? Quantum mechanics will say that unless you don't wave it, you assign a wave function to it. And what basically happens, this book is not at this position. This book will be something like in between these all points, and it is not a particle. It is spread as a wave. This book is not basically solid object like this, but it is spread as a wave, more like as a wave packet between all this position. So that is that between this and this position, you can only calculate the probability of the book lying between this and this position. That is why you cannot ever say this book lies at this position. What you can say is that if you are given this position and this position, this much probability it will lie between this much probability it will lie between this much probability it will lie between this. That is what you calculated for. On the other hand, in relativity is also a classical physics. That's the interesting point. Relativity in the beginning it came and it introduced everything of modern physics. But now, even though at that time we consider relativity to be modern physics, and still you will find it in modern physics section of textbooks, but actually now relativity is also a classical theory. More like physics, more not like physics, it is more like a classical theory. Relativity, exactly, you might not say classical physics, it's now called a classical theory. Even general relativity is a classical theory. What's modern